Welcome to our statistics video where we'll solve a problem about frequency distribution, measures of central tendency, and data visualization. Let's look at the given data first. Let's start by creating a frequency distribution. Step 1 is to organize our data. We'll create appropriate class intervals. Looking at our data, we can see the values range from 0 to 97. We'll create class intervals with a width of 10, starting from 0 and ending at 100. Now, let's count the frequency for each interval. Now, let's calculate three measures of central tendency: the mean, median, and mode. For the mean, we sum all values and divide by the number of students. The sum of all grades is 2,462, and we have 50 students. So the mean is 49.24. For the median, we arrange the data in ascending order and find the middle value. With 50 values, the median is the average of the 25th and 26th values, which is 38. The mode is the value that appears most frequently. The value 16 appears 3 times, making it the mode. Let's interpret these measures of central tendency. The mean of 49.24 represents the average grade of all students. It's influenced by extreme values like 0 and 97. The median of 38 indicates that half of the students scored below 38 and half scored above. The mode of 16 is the most common grade, appearing 3 times in our dataset. Comparing these measures, we can see that mean median mode, which suggests a right-skewed distribution. Now, let's create a histogram to visualize our frequency distribution. The histogram shows the frequency of each class interval. We can see that most students scored between 10 and 39. The histogram confirms our earlier observation that the distribution is right-skewed, with a longer tail extending to the right. Now, let's move on to the second question, which asks us to create a scatter plot and regression line for study hours and exam scores. Here's the given data. Let's create a scatter plot to visualize the relationship. Each point represents a student's study hours and their corresponding exam score. We can see a clear positive relationship. More study hours generally lead to higher exam scores. Let's now find the regression line for this data. The formula for the regression line is y equals a plus bx, where b is the slope calculated as b equals sigma xx yy slash sigma xx. Superscript 2 after calculations, we get b equals 2.93 is the y-intercept calculated as a equals y, b times x after calculations. We get it equals 35.76. So our regression line equation is y equals 35.76 plus 2.93 x. Let's plot this line on our scatter plot. Let's interpret our regression analysis. The slope of 2.93 means that, on average, for each additional hour of study, a student's exam score increases by 2.93 points. We can use this equation to make predictions. For example, if a student studies for 14 hours, y equals 35.76 plus 2.9, 3 times 14, is equal to 76.78. So we predict an exam score of about 77 points. The strong positive trend suggests a high correlation between study hours and exam scores, indicating that increased study time leads to better performance. Let's wrap up what we've learned today. For question 1, we created a frequency distribution, calculated measures of central tendency, mean, median, and mode, and created a histogram that showed a right-skewed distribution. For question 2, we created a scatter plot showing the relationship between study hours and exam scores and fitted a regression line that showed a strong positive relationship. These statistical tools help us understand patterns in data and make predictions based on observed relationships.